Hi there. This is session 8 of programming from the very basics using Python. In this session, we'll learn all about Boolean expressions. I did cover comparisons in the earlier session. I guess in session 6, I did talk about how do you compare values by using equality, less than, greater than. I'll quickly recap that and cover all other Boolean operators that are available and also talk about a couple of these Boolean logical operators and how to use them. And I will also tell you about the ternary if expression in this particular video. So let's get started with the quick recap on the comparison operators. We learned how to compare numbers. If you remember, I just said a is equal to 10, or I could say b is equal to 20. And I can compare these two numbers by using the expression where I could type a is less than b, a is greater than b, a double equal to b, a not equal to b, and a less than equal to b, and a greater than equal to. All of these are the different expressions which I'm just trying to recap, where I told you this is to check whether the left hand operand, whatever value it's representing, is it smaller than the value represented in the right hand operand. This is for greater than, checking whether both values are equal, then not equality operator, less than or equal to, or greater than equal to. So these are the standard comparison operators primarily used with numbers, mostly numbers, right? When you're dealing with strings, how does it work? Let's try. First of all, I'll try to show dissimilar data. Suppose you say a is equal to 10, b is equal to, let's say, 10 as quotes. If I try a double equal to b, what do you think would be the answer? Would it be true or false? Think. Well, both have similar values, isn't it? But here's the thing, when you try this outcome, it is false. In fact, comparing a number 10, which seems to have a value, with a string that has a value 10 is not really equivalent. It's like trying to say that comparing my phone number against my bank balance. My phone number is just a number. It does not have any inherent value. My bank balance has a value. You don't want to compare them. They are two different things, right? Though they are numbers, you treat the phone number as a string, you treat your bank balance as some kind of mathematical number because you can have that increased, reduced over time, right? So when you want to compare data, it always makes sense that both operands, both operands for the equality operators must be as this in the same type, right? Must be of the same type. Sometimes you can have some flexibility when you're dealing with numbers. For example, it's okay to compare integers with floating point. It's fine. You can compare integers floating point. Now, what about strings and strings? Let's try that. What if I say a is equal to 10 and b is equal to 10 and try this out? You can see that it is true. If I try a is equal to 100 and a is equal to 10 and b is equal to 100, obviously it's false. When it comes to string comparison, when you use double equal to operator, it's going to compare the contents of the string and make sure that they both are identical in nature. That's what it does. So if you want to compare two strings, use equality operator. But now you might ask me, can I use something like less than or greater than for both operands that are strings? Let's try this. A less than b, true. Wow, it's showing true here. And let's try a greater than b, false obviously. Let's try this out. Let's try 20 here. And now check this. Interesting. 20 is greater than 100. How is that? You can see both operands are strings. When you're comparing strings, the comparisons are lexicographic. So strings are compared in a lexicographic manner. What is this lexicographic manner? It's basically this. It's going to check the first character of A against the first character of B and figures out which character comes first in the ordering, in the sort order. If you try to sort all the characters, they fall in some kind of a sort order, right? So in this case, you can obviously see that 2 would come after 1. So obviously A is greater than B. So it's coming after 1, right? Suppose if I had actually made this as 3 here, and I'll only have 3. Now A is greater than B. What do you think is the answer? Let's try it. False. It's actually the reverse. You can see that B is greater than A. You can see the result would come up like in a tuple because I have comma separated two expressions. When you have comma separated expressions, each expressions will give out some value. So you have comma separated values ultimately. And when you have comma separated values as the outcome of some expression, it creates a tuple. You can see the output is a tuple, right? So you can see it's false and true. The first answer is false and second answer is true. So you can see that the comparisons are based on character by character. It is most useful to find out not with numbers, but is used with normal strings with letters. For example, if all I try this, if I try maybe A is equal to, maybe I'll try Adrian, and B is equal to Steve. If I want to sort this out alphabetically, what do you think should come first? Obviously, Adrian, right? So if you just try this out, A less than B, true. But I'll try something else like, say, Tim. A is Tim and B is Steve. Obviously, I guess that Tim should come after Steve. But here's a problem. The number of characters are different. Let's see what's the outcome here. But still, it's false. So, irrespective of number of characters, S is smaller than T in the lexicographic ordering. So, that's exactly how strings are compared, right? So, most data structures or different kinds of data will have different kinds of comparison, right? So, it's how it is. It's like in real world, if I say I am bigger than you, if I have to compare myself and say I'm bigger than you, how do I say I'm bigger than you? Maybe my size. Obviously, I'm not a very big person, right? I might be an average height, but I'm not really bulky and all that. But anyways, so you can see that maybe size may not be the case. Maybe I'm elder to you. Maybe that could be a case. But maybe it might not be the age. I might be considering my salary, my net worth. I can be bigger than you because my net worth is higher, or different reasons, right? So we don't really know what should be the actual comparison factor. It depends, right? It depends on the context. So when you look at strings, the context for comparison is the order of characters. When it comes to numbers, obviously a numerical value. If you take other data types like, say, collections, it depends on their implementation. What kind of elements are there in a collection? Those elements ordering might matter. So comparison would work differently based on the kind of objects you're dealing with. And when you have objects of different data type being used for comparison, the result can sometimes be very ambiguous. So you should make sure that you know that you're dealing with similar data types. But actually, Python, I don't think will raise an error if at all I try this. If I try to say maybe, A is equal to hello and B is equal to 10, 20, 30. You know what is A? It's a string. A is a string. I put type of A and type of B. We know by now that the first variable represents a string object and the second variable is representing a tuple, right? These two identifiers, they are representing two different data types, objects of two different data types. If at all I try A is less than B, oh, that's nice. It shows type error. In some cases, you can see that when the types are totally incompatible, string and tuple, you just can't compare them, right? It's like comparing apples to oranges, you say, right? So you can compare them. So that's why they raise a type error. There are certain data types where things could be relaxed, so they might actually just return false or true based on what they look at. When it comes to numbers and strings, we saw that, right? It did not really raise an error. But when it comes to string with tuple or number with tuple, might actually raise an error. So it varies based on the data types. For all considerations, if you want to compare, ensure the objects as much as possible fall in the same category. Numbers can be compared with numbers, right? Mostly you want to keep it to integer with integer, float with float, right? To be very consistent in your code. So, anyways, so talked about how these comparisons work. But that's not all. These comparisons are nothing new in Python. This has been there in most other programming languages. But there are two more comparisons that are interesting in Python. Amongst that, one of them really caught my attention when I was learning Python the first time. I said, wow, why isn't this there as a standard feature in most other general purpose languages? And I will tell you what that is. Suppose if at all I have a collection, let's say a tuple, I just use something like values equals some random numbers in it. So I have a tuple here with some values in it. I want to know whether this tuple has an item 12. I want to know whether 12 exists in this tuple. In many other languages which I had worked on, there'll be some functions or methods that actually check these. There'll be like dot exists method or has method and all that. But you know how it's done in Python? You would actually say directly, you could try 12 in values. The in is a standard built-in operator, just like equals, double equal to, or not equal to, or less than, greater than. In is an operator where the left-hand operand is an item, the right-hand operand must be a collection. I'm making it very clear here. The left-hand operand is an item, the right-hand operand must be some kind of a collection. So this will return true if this collection has this item. If 12 is there in this collection of numbers, then it is true. Now use the word collection, which means that it doesn't just work with a tuple, it will work with a list. You try with a list, no problem, it's going to work. Try it against a set. It works even with a set. And I told you how to create a set, right? You can just use curly braces, comma separated items, and end with curly braces. So if you want to check for existence of an item in a list, tuple, or a set, you can simply use the in operator. But what if you want to check it on a dictionary? The meaning is a little different for a dictionary. The in operator is used to check whether a key exists in a dictionary. Not the value, the key. I guess you remember when I talked about dictionaries in my earlier sessions. I told you dictionaries are nothing but collections of key value pair, right? So I'll just recreate a dictionary for now, a simple one at that. I just call this as, record. Rec is equal to, I'm going to give some record, let's say temperature, colon, I'm going to use some number like the 26, and humidity, colon, let's say 50, and wind speed. I know what it's measured in, but I'm just going to put a number there. I'm just going to put some number, like say 67. I don't know if that's good or bad. To be honest, I'm not a meteorologist or not into that space. What else can we add about environment? Maybe, okay, I can just use raining and false here. So this is one of the ways you can create a dictionary. This is the literal notation of a dictionary. Just like you have literal notation of a set, tuple, and a list, this is how you literally create a dictionary. It's a key value pair. So keys can be either strings or numbers generally. That's what keys must be. Mostly they're strings or they're numbers. Rarely they're numbers, mostly they are kept as strings. That's a very common convention in dealing with dictionary. We'll go deep into it the later sessions. Values can be anything. Values, I'm using numbers here, but instead of numbers, you can have any arbitrary types and such. And this is a pair. This is a key value pair. This is another key value pair. And so is this. And so is this. So when I create a dictionary like this, I can even print rec, type of rec. You can see that it shows up as a dictionary. This is just another kind of organized collection. You can organize collection of items in different ways, right? You can organize them in a very ordered sequence. That's what lists and tuples are. Or you can keep them totally unordered. Or you can have those collections with some labels for each item, and those labels act as keys and the item are the values. Right? That's how you can have them. right? There's a dictionary here. So in this dictionary, I want to check whether raining, a key called raining, exists. How do you check that? You can directly try raining in lake. That's it. The in operator is quite smart. It works it works differently based on the actual collection you're dealing with. When it comes to tuples, list, and set, it checks for an existence of an item in them. But when it comes to a dictionary, it checks for existence of the key in a dictionary. If it does not exist, obviously it'll return false. It's a boolean expression, so the written value will be either true or false, not an error. So you can just see that. Let's say I misspelled raining with something like this. Obviously, that's a misspelling, right? A key like that does not exist. If you try this now, you can see that written value is false. Now, this is how you can use in operator for all the collections. But you know that strings are also collections. Strings fall into the category of sequenced collections. What is a string? String is a sequence of characters. Oh, even the byte string is a sequence of bytes. Okay, so these are all sequences. But when you're dealing with a string, it works a little differently. Suppose if I have a string like this, I say s is equal to, this is a test string with a couple of useless words. All right, I just created a dummy string here. Nothing useful, just some words. And I want to check whether this particular string has a word called test. How do I do that? Test in S. So you can closely observe. Though a string is a sequence of characters, I'm not checking for a single character here. I can look for a substring. I can check whether a word called test exists in the string. So if you want to check for existence of a substring to just know whether it's there or not, you can use the in operator. The later session when I talk about string operations or strings in general, you will see there are many things you can do with a string, and string has got a lot of methods, things that can operate on string objects, where you can find out, you know that test exists, but where? How many times does it occur? Right? All those things can be checked. So there are string methods to do that, which I'll discuss in the future sessions when I talk about strings specifically. For now, you can see the generic nature of the in operator. So in checks for an item in a given collection. For a string, it's like it's read as substring in a string. Check for a substring in a larger string. If it's for a dictionary, it checks for existence of a key in a dictionary. And if it's a list or a tuple or a set, it just checks for a given item in a list, tuple, or a set. So this is how it works. And yes, because I'm using some little data here, some people newbies might ask me, oh, can that be a variable? Yeah, it can, obviously. So wherever I'm using a literal values in an expression, you can always substitute it with a variable or an identifier that represents the data. Maybe I could have A is equal to test in string quotes, and I could say A in S. That'll work. You can try it out, right? So this is something that you know about the in operator. The opposite of in operator is not in operator. You can also use not in operator. You can just maybe you can just do this. Maybe I'll go to the previous cell here. I want to confirm that a value called 20 is not there in values. An item with the value 20 is not there in this set called values. So I can actually say type, I'll put it here, 20 not in values. You will see these words in, not in, reads like English, and when the moment you put them in more complex clauses like if condition, it reads like English. You can say if 20 not in values, print not found. It reads like pseudocode. Very interesting. So these are two operators which are there in Python, in and not in. This is one set. And there is another operator. And if I'd explain that, I had to go, unfortunately, deep down into a bit of internals. Right? Ready for it? Okay, let's try. Let's give it a shot. I'm going to try this. A is equal to 1000. B is equal to 1000. They're identical values, isn't it? They are. And I didn't use any quotes. So obviously they both are integers that I've created. So A is an integer, B is also an integer. I mean, A is referring to an integer object. B is also referring to an integer object. That's how you see it. So when you try to print A and B, type of A and type of B, you could see them here. Are they both equal? It's pretty obvious. They are. A double equal to B. They're equal by values. So the next question is, are they the same value? Are A and B pointing to the same object? Wow. Is that possible is a question. But let's first answer this as such. How do you check whether two operands are referring to the same object? It's possible. You can have a single object with multiple labels on them, right? Here's my labels. Okay. What I could find here. Oh, I got this. And my previous session, I think, used this. What is it called? I mean, it's a marker, not a marker. It's a I don't remember stationery names. I don't even know what it's written as. Highlighter. Okay, highlighter. Sorry about this. Yeah, I have a highlighter here and I have one label. One label. There's one variable referring to this. Maybe I could have labeled it something. I could have written something here. I could actually even write it. Just one moment, please. When I need a pen, I won't get it. Let's call this A and I stick this label. So this is A. I'm not able to see it. I don't know if you can see it. Can you? No, I don't think so. I think I need a darker marker. Sorry about this. Never mind. I'm so sorry. Everything is like spontaneous here, and I couldn't find my marker when I need one. But never mind. I'm just going to type it as A here, and I have only one. Unfortunately, both of these labels look similar in color, so I just put one. I think you can see it now. It's A, and I can also have another label here, and I'm going to label this as B. I have a single object, but nothing stops me from adding two labels here. Two labels. I can refer to this object either as A or as B, and it works, right? It's possible in Python that you can have a single object, but multiple identifiers refer to the same object. So the object has multiple reference. Multiple reference. So there are multiple references to this object. So it's like multiple people who are referring to this object. It's like this. The only joking example I can think of is this, a movie called Born Identity. I'm sure you watched that movie or even maybe read that novel. I have not read the novel. I watched the movie though, where you can see that one person, he does not know what's his name, and he goes to this bank, his Swiss account. He figures out his Swiss account and he opens up his safety vault and he finds many passports and he's not really confused. Who is he really? Is he Bone? Is he somebody else? We don't know. I mean, he's got so many names, right? So, an example. It's just a silly example. So, like one person with many passports, right? So, it's like that. So, it's possible in Python that you can have one object with multiple references, multiple identifiers to it. But is that the case here? How do you know that? We can try this. I can try A double equal to B is true. By values, they both look similar. But if I say A is B, this is a sure test. This is operator is going to check whether both operands are referring to the same object. Whether two operands are referring to the same object. Get my point? Suppose if at all how do you create that? How do you create two references or more references to the same object? It's very easy. I will tell you how that is done. I'm just going to copy the cell so that trails are maintained. Oh, by the way, I forgot to update it in my YouTube description for some time because I could only upload it today. All these notebooks and samples which I'm typing so far, some of you might wonder, oh, is there a way I can get these notebooks so I'm lazy. I don't want to type everything from scratch. I want to take your notebook and try it out. Is there a way to get that? Yes, I have updated the description of all my videos. There's a link to a GitHub URL. So you can go and get all the sessions so far from the GitHub URL. Session 01, session 02, session 03, you'll find them. If you go to that URL, the GitHub repository, you can just download the file and you can open it up in your editor and use it. Right? All the samples which I'll be using for demonstration, henceforth I will be updating in that GitHub repository. So after this session, after this video is uploaded, I'll also make sure the link to this notebook is also available there. So I'm just going to maintain some trails and scribble notes for your reference. So it's not like a very formal documentation. I'm not that kind of a person. So I speak out documentation. Okay. I don't type documentation as much. So you can listen to me, look up the notebooks and customize, make some alterations and learn from there. Right. All right. So here's this. I'm going to make a copy of the cell as I just mentioned. As you know how to copy a cell, escape, make sure you're in command mode, C to copy, V to paste it. C and V. It's like Control C, Control V. Works the same thing. So here I made a copy of this. And I'm going to add another variable here. Another variable. This time, I'm going to say C is equal to A. Interesting. I said C is equal to A. For now, I'm just going to print the value of A, B, and C. A, B, and C. The first time, okay? First, let me just print this alone. The value of A is this. The value of B is this. And the value of C is printed, 1000. So 1000 is printed 3 times because A is 1000, B is 1000, so is C. But now I'll show you something interesting. Of course, if I say A double equal to B, A double equal to C, the values are similar. So obviously the equality operator is just going to work this way. It's going to say it's true because 1000 is equal to 1000, 1000 is equal to 1000 by value. But then if I try A is B, A is C. Interesting. You can see that A and B don't represent the same object, but A and C actually refer to the same object. So you have 2 references to this object. 2 references to this object. At this moment, I should also tell you, if you come from a programming background like Rust, it's a new language, this is a violation. They have a so-called borrow checker algorithm where you're going to have multiple references to the same object. If you take a reference, the old variable loses the reference. You borrow, right? It's like money, imagine this, I have maybe $100 bill with me and I pass it on to you. I don't have $100, you have it. That's a reality. But here's like both of them have put their hands on $100 and there's a $100 bill. We say, I own it and you also own it. Both of us refer to it. That's what it is. So there are 2 references to the same object, right? So you can see this. You might ask me, is there any practical use case for features like these? As I told you, these are mostly about the internals. One thing you learn here is all assignments in Python. All assignments copy references and not objects. So assignments copy references and not objects. What do I mean here? What I mean by copying references and not objects? It's like this. A is referring to 1000. How does it refer to 1000? For a label A, the corresponding value would be a memory address of the object 1000. I told you that everything is objects in memory and they all live in some addresses, right? So A has a corresponding memory address of 1000. When I say B is equal to 1000, another copy of 1000 is created in memory. Another copy of 1000 is created in memory, another object. whose value 1000 is created, which lives in a different address, and B corresponds to that address. So A refers to 1000 somewhere in memory, B refers to 1000 somewhere else in memory, right? So they both are living at these are two different references to two different objects. There are two references to two different objects, right? However, when I said C is equal to A, whatever address is associated with A is copied to C. The address is copied. So A and C point to the same address. I'm showing hands. I'll do one thing. I'll just bring up a small tool to demonstrate this better. Sorry. I think I was trying to look at Odyssey. But anyways, I was trying to get my videos, checking whether it's mirrored in Odyssey. Discard. Discard. Okay. Yes. Oh my god. Okay, I can't believe this. All my old techniques. Decide later. I'm just using a simple drawing tool, very rough cut drawing tool. So let's assume that here's an object in memory which is having the value 1000. And this object, this value is 1000, lives in some address. And addresses are just numbers. Memory addresses are just numbers, right? Locations in memory. And we also call them as pointer addresses in language like C. So let's give some arbitrary value for the address. It could be anywhere in memory. It's sort of like, I could say in a way it looks quite random. It's not deterministic, depending on how your program runs, right? So I'm just going to put some number, and it's customary to use some hexadecimal number. Let me increase the font size. Is there a way to increase that font size? It's too small. Yeah, I like this. Let me increase the font size of this too. Let me make it big. Yep. It is an integer object called 1000, which lives in some address, and let's assume it's called 0x. I'm just going to use address in hexadecimal. I'm going to use small numbers. Okay, normally addresses could be like 64-bit, 32-bit. It varies. You know what? We can actually find out the address. I will better do that. Okay, so why spoof it? Let's find out in reality. If you want to find out memory address of any object in C Python, the official Python implementation, you can simply use a function called id. id function returns a unique identity of an object. So if I say id of A, id of B, and you can try id of C. Just like you have type to find out type of an object, you can say id to find out the object's location. So all these numbers are shown in decimal. Nobody likes to see memory address in decimal. No programmers like it. So let's try to print it in hexadecimal. So we'll try to use hexadecimal notation of it. Same thing, hex of id of A, hex of id of B, hex of id of C. id returns a number, that's an integer. Hex creates a hexadecimal string representation from a given integer. So you get the point here. We can see this. And you can also observe that A and C have the same addresses, as B lives in a different address, right? You can see that. 70832, 70032. Yeah, that's the only thing that changes, isn't it? Yeah, looks like it. They're very close by. They're neighbors anyways. You can see in hexadecimal also. You can see them here. So let's take this hexadecimal number and associate it with A. I'll just copy this, and you can see I'm just going to put this here. I hate this. The font size changed. All right, so I did that. And this is the object 1000 in memory, but this address, it lives in this address. There is one of these dictionaries that Python maintains, key value pair. Python maintains a dictionary. It's done internally in Python. Later on, I will show you that dictionary. We can actually see that. It's beautiful. In fact, this dictionary's got key value pairs. Let me just put this dictionary like this. I mean, there's no ready-made block for that, so I need to do it the hard way. So I can just create one block for the key, another one for the value. There's one key value pair. Let's assume there's another key value pair. And maybe there's another key value pair here. Remember in the previous sessions, I told you that, Python variables act like labels, and these labels are stored in a common registry. And that's what I'm drawing up here. There's a common dictionary. It's like a ledger. It's like when you walk into a room, there's a ledger that shows where all the items are found. You look at the ledger, okay, this item, located here. This item, located there. This item, located there. You look at the ledger and figure out where to locate the items. That's exactly this dictionary, right? So here, the key of the dictionary will be the name of the variable. I use a variable called A, and I hate this font. I think all the fonts are small. There's a way to make this default 24. I think I should do that. Yeah, let me. And yeah, let me just, I need to make room for storing a large value here. This is what is stored in the dictionary, right? So I think I'll copy this, paste it here. Ouch, no. Yeah. Again, I guess you get the picture anyway. So it will be easier for me to just copy these cells now. Just copy this, paste it one more time, paste it one more time. Initially, when I said A is equal to 1000, an object which represents the value 1000 is created, which is an integer object in some memory address. And that address is written down in here. Don't worry about this right now. All these are blanks. Okay, don't worry about this. Okay, it's one will B, the other one will be C. I'll tell you about those addresses. So this address is stored as value, which means essentially this is pointing to this object. A is having a value that's a memory address of the location of the object, and that's how that reference is created. So A is like a tag, it's like a label. And for the label, you have an address associated, and the address is the location of the object. When I said B is equal to 1000, another object like this is created elsewhere in memory, somewhere else in memory, somewhere here, let's say, right? And this lives in a different address though, because it's in a different location, as you can see on the screen. And the address of that, let's copy this. It's what's changing here? The only thing that changes is at the end, it's EB0. Okay, let's make that small update here. EB0. As per what you see on my Python environment, this is the locations of these two objects, and B would be having corresponding address as EB0. So you can see, these first numbers look identical. We look at the last number. The address is here. There's like a close neighbor. The address is somewhere else, right? And this address corresponds to this object. It's because B is corresponding to the address, and that's representing this value 1000 that you see here. When I did C equals A, what am I doing? I'm assigning A to C. When I make an assignment, what is happening in reality is this address just got copied here. This address got copied. Yeah, I think whenever I copy that, this font changes. Let me just bring up the font to something that's legible. Because you copy the same address here, C corresponds to an address which is the same address as this object that A refers to, isn't it? This is what I mean by telling assignments copy references. This is the actual reference. The reference is copied. The reference is the memory address. That has got copied. So this A and C are aliases to the same object. You can access the same object as A, or you can access as C, right? And we can verify whether two operands are referring to the same object by using the is operator. You'll understand the real benefit of figuring these things out, whether two operands are referring to the same object or not, when I talk about mutable objects and immutable objects, which is a big topic. Another session will be dedicated for that. So I'll talk about in great depth about mutability, immutability, and the benefits, hashability, and all that. That's all the concepts which I will cover in the next couple of sessions. All right. So this is what you should know. So this is the outcome of assignment. So all assignments, it doesn't matter what data type you're dealing with, whether you're dealing with strings, numbers, list, tuple, no matter what you're dealing with. If you're assigning an identifier to another identifier here, what you're effectively doing is that you're making both of these identifiers point to the same object. And this object has more than one reference. More than one reference, right? This is what happens. Any questions? So I hope I made it clear, right? So if you have any questions, you can always post it on comment. All right. So I use the is operator. The opposite of is operator is not operator. So what is not operator do? Opposite of it. I can actually try this. I can just say A is not B, A is not C. I can see the outcome of it. I can see the outcome. True. A is not B is true. A is not C is false. So to summarize, the double equal to operator, that is the equality operator, checks whether the values of two operands are identical. Whether the values are identical. It's value comparison. The double equal to operator compares values of operands. The is operator, on the other hand, checks whether both the operands are referring to the same object. Both operands are referring to same object. That is a major difference, right? So you'll understand when you're getting a little deeper into Python, when you start writing slightly sizable code, all these things really matter. So you understand the internals better. So you can troubleshoot issues better. Or you can also design your code better. So all these concepts really are worth learning right from the basics, right? All right, so I talked about all these is and is not. So boolean operators, I think I told you about all the comparison. Equal to, not equal to, less than equal to, greater than equal to, less than, greater than. That's standard operators, we call them. The next set of operators are what? In, not in. Is not, not is not. Okay, the English, it falls in English grammar style. Okay, so the opposite of in is not in. The opposite of is not. Okay, so you can check this right here. So these are the Boolean, miscellaneous Boolean operators you should be aware of. The next thing I should now talk about is the Boolean context. Before I talk about Boolean context, I will talk about the logical operators. What are logical operators? Sometimes you want to check multiple conditions, and you want to take decision based on checking multiple conditions. Let's take an example. Let's say maybe, temperature is equal to 26. Or maybe I can take it as user input. This time I'm going to use int of input of enter room temperature. This time I'm typing this in my Jupyter notebook. If you try using input function in Jupyter notebook, first time you might find it a little counterintuitive. I will show you why. You run this. And you look at the screen here, nothing happens. You will see some numbers ticking. You know what? It's expecting input on top. You can see on top. I found this a little counterproductive because normally your eyes are focused on the cell. We are expecting input to come at the level of the cell, but this is what happens when you use Jupyter Notebook in VS Code. If you use Jupyter Notebook as is, without VS Code, when you type Jupyter Notebook in the command line, it comes below the cell with a small text box. That looks okay. But here, whenever you use input function in VS Code, and you run that program, expect the input to come up on top here, which you can see right on top. Okay, it shows enter room temperature, press enter to confirm or escape to cancel. Okay, let me type in the room temperature here. Let's try 26. And as you can see, input returns a string, but I want the value to be in integer. So that's why I use the int constructor. If you want the return to be a floating point, you can use a float constructor. So construct a float from the return value of input function, or construct an integer in this case from the return value of input function. That's why we say int of input of prompt, right? This is very common idiom used. And if you try to print what temperature is, oops, I think, you know what? I got the answer for temperature in this cell. I can print it in another cell. Perfectly okay. The cells are not completely independent. Whatever variables or identifiers you define in one cell, you can access in the successive cells or even before it. Once you define it in any cell, you can access in any other cell, right? You can always access temperature here if you really want to test it. I typed 26, I got 26 here. But I want to write a slightly larger program. What I want to do is I want to take in the temperature from user input. I don't want to decide what's the temperature. I want to ensure the temperature is within a particular level, between a particular level. And how do I do that? Maybe I can just do this. I can just say temperature is greater than, must be greater than 20 degrees. If my room temperature is less than 20, I will shiver. And temperature is less than 30 degrees. 20 to 30 is a very tolerable limit for my room temperature. If it goes beyond 30, I feel a little too sweaty. If it goes below 20, I feel the chills. So I want to make sure the temperature is between that range. I want to check whether it's really in that range. That's it. And you can see closely, I've used a new operator called AND. What does AND do? It connects to expressions. And what it does is, if both expressions evaluate to true, only then the return of the entire set of expressions, I would say, right, is true. That are collective, it shows up as true. So if any one of the expression is false, the result is false. So the outcome is false. You can just try running this now. If I try to type the room temperature as something like 18 degrees, it's very cold. False. Try running it as, let's say, 34 degrees. False. If I try maybe 25 degrees, 25, is the spot that actually ensures that both conditions are satisfied. 25 satisfies both of these conditions. It checks, is it greater than 20? Yes. Is it less than 30? Yes. When both are yes, the result is true. If any one of them is no, the result is false. Like we use and in real world. It's like the link. If it's raining and no, it's not like that. If it's not raining and my friend calls me up, I will travel out to meet my friend. If it's not raining and my friend calls me up, if any one of the condition is false, where if it's not raining is false because it's raining, and my friend called me up, I can't go. It might not be raining, but my friend doesn't call me up. There's no reason for me to go out. So you can see that sometimes you have to satisfy both the conditions. That's what and is. Right? If at all instead of using and, if I use or, it's opposite of it. If any one of this is true, any one of the conditions is true, the outcome is true. For example, temperature greater than 20. Maybe that's false. Is temperature greater than less than 30? The temperature that is greater than 20, that's false, but temperature is definitely less than 30, right? That's true. If one of the conditions is true, the outcome is true in this case. If any one condition must be satisfied, either this condition must be satisfied or this condition must be satisfied. This or that. Because I sometimes say, I want this and I want that. Both must be required. Both conditions must be satisfied. That's what and is. Or either I need this or I would have that. Any one will do. I'm giving a choice here, right? So this is a Boolean logical operator, that's it. One important thing I should tell you, people who come from programming backgrounds like C, C++, Java, and many other languages, the mainstream languages, they have learned using double ampersand and double pipe symbols to represent and or operator. That doesn't work in Python. In Python, instead of double ampersand, you're supposed to use and or like this. And one more common question is, people ask me, should I not parenthesize them? Most people have the habit of doing like this, they will put this like this. This is to ensure that the order of precedence is correct. So you want to make sure that comparing the temperature must be done first. Comparing this temperature must also be done at higher precedence than comparing the outcome of this and outcome of this. That's what parenthesis actually means here. But you know what? You don't have to do that in Python. There are some languages where the order of precedence is completely botched up. I can recognize Perl. Perl is one such language. That's why there are way too many confusing operators. There's and or and there's a double ampersand double pipe, and both of them have different order of precedence, and we always get confused which one to use when. So when in doubt, we parenthesize. But in Python, you don't have to worry about this because they have thought about it. The and or operators have the lowest of precedences, the lowest precedence. So all other operators work first before and or operator. So you don't really need to parenthesize when you're using comparison. They have definitely a lower precedence than all kinds of comparison and all the Boolean comparison operators and in, not in, is, not, is, no, is not operators I talked about, right? So these are lower precedence. So you don't have to parenthesize. You can just leave it as is. The point is, I've also seen a common trait where a lot of developers who come from other languages, especially C, they try to write Python program like it looks like a C language, and they have carried forward all that C-like grammar, and they try to put that in Python. One of the things is using parenthesis where it's not really required. Avoid it. When you write Python, follow the Python way. Use the Pythonic idioms. So don't parenthesize when it's very obvious. This is a very obvious thing, right? Temperature greater than 20 or temperature less than 30. Looks real. There's another interesting feature that Python has, which I see lacking in many languages I've seen. I see C and C++ lack that. And that's an interesting one. You can chain load these comparisons very nicely. See, this, in my opinion, is not really Pythonic. I want to check whether the temperature falls between 20 and 30. I want to check whether temperature falls between the range 20 and 30. You know what's a Pythonic way to check that? I could use this. I could directly say 20 is less than temperature, which is less than 30. This gives you the same result as this operator. Gives the same result. You can see that over here. Try running it. Try temperature of 18, false. Run it. Temperature of 34, false. Try running it again. Temperature of 25, true. So this is a more intuitive way of telling to say that 20 is lesser than temperature and the temperature is lesser than 30. So temperature falls between 20 and 30. So you don't have to write these kind of complicated conditions. You can make it more Pythonic like this. Something that you know, right? Pythonic approach. Check for a number within a range. So check for any number and ensure that it falls within a particular range between the minimum and maximum. Minimum less than the number less than maximum. Where I use a number, it can be an identifier that's representing the value, right? You can use that. So this is how you can wire up your expressions, right? All expressions. You can also make it like 20 greater than temperature greater than 30 years. You can make any kind of variations of them. Make sure it's falling in the proper range. Okay. Actually, 20 greater than temperature greater than 30 doesn't make sense. You can say 30 greater than temperature greater than 20. That will work, right? So you can use that analogy if you want to. All right, then. So I talked about all these Boolean features, right? Boolean construction features as such. And the next thing I talk about is the Boolean context or truthiness. We call them as Boolean truthiness. Context. There's a Boolean type. So there's a boolean construct. You can construct a boolean out of any object. Any object. So suppose if at all I say bool of 100, if I ask 100 as a boolean, what are you? Are you true or false? 100 will report as true. Every number will report as true. Every number. The only number that reports as false would be 0. Try everything out. Boolean of 100. Bool of maybe minus 34. Random number, okay? A negative number though. Bool of, by the way, that minus is a unary operator. Negates a number, okay, by the way. So bool of, I can try maybe 4.5. Bool of 2 plus 3j. All of these report as true. So for a number, the number must be false. I mean, a number must be 0 in order to be treated as false in the Boolean context. So when you say bool of 0, this will return false. So bool is a constructor, just like int, float, str, list, tuple I talked about in the previous session. So you try to construct a Boolean passing any argument. Whatever argument you pass, you'll check that object's truthiness. And different objects will work quite differently. When it comes to numbers that are 0, which evaluate as 0 alone, are treated as false, and every other number is true. Every other number. You can try it out. Try every number. It will be true. Only 0 is false. What about strings? If I'll try a string like this, what do you think is the answer? If you're a Perl or a PHP developer, you'll say, yeah, this should be false. Yeah, Perl and PHP developers will tell you that's false. But you're a Python programmer, you should know that this will be true. For a string to be evaluated as false, or in general, for any collection to be evaluated as false, the collection must be absolutely empty. There should be not a single item in that collection. So what is treated as false here? The string must be empty. An empty string, just put a double quotes. There's no space in it. Even if you put a space, it is true. There should not be even a space in it. A space also is a character. So a string that's absolutely empty is like your open quotes, close quotes. That's an empty string. String has absolutely no item. That is false. Not only that, empty tuple. Empty tuple is represented as simply open close parenthesis. You can see a double parenthesis inside. That's because it's another empty tuple inside it. Empty list. Empty dictionary. How do you create an empty set, you might ask me? This is how you create an empty set. Sadly. Because you can see that braces is used both for a dictionary and also a set. The difference is for dictionary, you have key colon value, comma, key colon value, comma, key colon value. But for a set, item, comma, item, comma, item, comma, item. But you still have braces. How do you say it's an empty set? If you remove everything, it'll treat as empty dictionary, not an empty set. You know why? The braces for set were introduced much later in Python 3.0. For a long time, braces were only meant for dictionaries. Set was introduced in Python as a late addition. Sometime in Python 2.4, it made it as a library. In 2.6, it became a built-in type, but they didn't use braces those days. They used only the constructor expression, set off, and you pass a list. That's the only way to create a set. It's only in Python 3 that, we can use braces to create a set. But now there's a problem. Actually, it's a problem. There are all of these uneven edges in Python. Unfortunately, we have to live with it. So here, this is how we create an empty set. Because this is an empty dictionary. So, but all of these, empty string, empty tuple, empty list, empty dictionary, empty set, and a value called false, obviously, and anything that evaluates to none as a result, all of these will be evaluated as false in Boolean context. Let me make it more complete. Number 0. Any expressions in Python that result in a value 0 as a number, or empty string, empty tuple, empty list, empty dictionary, empty set, any empty collection, or if it returns false or if it returns none, all of them are evaluated as false in the Boolean context. So you try to construct a bool out of it, it'll be false. How does it matter? When you use comparison, or not comparison, conditional expressions or conditional statements, that really matters. The moment you use conditional expressions and statements, that really matters. I think I will postpone the conditional expressions for another session now because we almost crossed 1 hour. But I hope you have learned something interesting in this session. So, to summarize, I talked about all the different Boolean expressions, how to use them. I told you about the Boolean context of your evaluation. How do you know that? By trying to construct a bool out of any argument. You know how that argument or that object passed as an argument is treated in the Boolean way, whether it's treated as true or false. And different objects would have their own rules to decide when they are treated as true or when they are treated as false. Right? I hope you found this particular session useful. So in the next session, I will continue with the ternary if expression, and I'll talk more about conditional statements. Right? So we'll meet you in the next video. Thank you very much. So as usual, like, share, subscribe, and share it with your friends. If you have anyone who might be interested in this kind of videos, slow-paced videos, share with others. Thank you very much. So meet you in the next video.